Hi guys, this is Miss Scott. As requested, I am making you a video of working through that Chapter 3 review for geometry. So let's jump right into number 1. We're going to draw the described angle pair. So the first one asks us to make congruent corresponding angles 1 and 2. So I know that if I want my corresponding angles to be congruent, got to draw two parallel lines and then cut them by a transversal. And if those two lines are parallel, all of my corresponding angles are congruent, so I'm just going to say this angle here is my angle 1 and this is my angle 2. And I could even put some arcs on here to show that those really are parallel lines and then that those two corresponding angles are congruent. Okay, let's take a look at number 2. We're going to draw a linear pair. So I know linear pair, the first four letters there make the word line. So draw a line, split it into two, and then the two angles that create that line are angles 3 and 4. Moving right along, acute alternate exterior angles, 5 and 6. So these don't have to be congruent, so really all I need to do is just draw two lines. They don't have to be parallel. And we're going to cut those by a transversal. And we're going to find our acute exterior angles. So I notice in the top, this is exterior and it's acute. Let's call that 5. Below the bottom line, this is acute. Those are alternate exterior angles and they're both acute. All right, number 4, consecutive interior angles 7 and 8. So again, let's draw two lines. There we go. They don't have to be parallel. Cut it by a transversal and pick one side of that transversal. Those are consecutive. Remember, consecutive means same side. Interior means inside, so 7 and 8 are consecutive interior angles. All right, now for number 5, it says to draw obtuse vertical angles. So vertical angles happen when you have two lines that intersect. And then we look at our obtuse angles. Well, here's an obtuse angle. I'm going to call that 9. And then on the right-hand side, right across from that would be angle 10. Okay, next, alternate interior angles 11 and 12. So for alternate interior angles, I need to have two lines. Doesn't say they have to be congruent, so I don't care if those are parallel or not. And 11 and 12 are going to be alternate interiors. So I'm going to call this one 11. And then on the alternate or opposite side, that's going to be my angle 12. Okay, so on the test, you're actually going to have a picture of these. And then you're going to have to just give me an example of types of angles based on that one picture. So we've had a couple of problems like that in your section 3.1 and 3.2 notes, so take a look at those. Okay, let's look at our next example here. In 7 and 8, find the measure of the numbered angles and give the reason how it was determined. So first we're asked to find the measure of angle 1, which is right here. And I noticed that that makes a linear pair with this 60-degree angle here. So if I take 180 and subtract 60 degrees, that makes 120 degrees for angle 1. And that's just because the reason is it is a linear pair with that 60-degree angle. Okay. Now let's look at the measure of angle 2 here. So we've got angle 2. Well, angle 2 actually corresponds with this 60-degree angle. So those both have to be the same. So that's got to be 60 degrees. And that's because corresponding angles are congruent. You know that? Okay. All right, now let's look at these true or false questions. In 9 through 12 use the diagram to determine if the statement can be assumed to be true. So let's look at this. Line TX is parallel to line RZ. So in this picture, we're actually going to assume that all of these are right angles. If it's a rectangular prism, we can assume that. So here's TX, and here is RZ. So those vertical lines are going to be parallel, so that is true. All right. Let's look at our next problem. We are told QT, so that's this line here, is skew to YZ. So if you remember, skew means that they're not parallel and don't intersect. Well, QT and ZY or YZ actually are parallel, so they're not skew because they are parallel. That is false. Okay, now let's look at the next one. Plane STY. I'm going to highlight that one. Plane STY is the back of this prism here, so this side in the very back. And they are saying that that is perpendicular to plane TXW. So here's T, here's X, here's W, so that would be this side of the box. So again, we're assuming this is a rectangular prism, so that would be true. Okay. All right, let's get rid of this. And number 12, we have angle RSZ. So here's R, here's S, here's Z, and YSZ. YSZ is here. So we're actually looking at the left side face, or the right side face of this box. So if we were looking at this straight on, it would look like a rectangle. Here's R, here's S, here's Y, and here's Z. And again, since I told you guys this was a rectangular prism, you can assume that those are all right angles in that rectangle. And angle RZY, or RSZ rather, so let's redo that. R to S to Z would be right here. And then we'd have angle YSZ would be right here. Well, I told you this was a rectangular prism, so we would assume that that is a right angle, so that would be true. Those are complementary because they'd add up to 90 degrees. Okay. Now let's look at some sketching here. In number 13 and 14, it says create a sketch. Include proper markings, measures, and labels. All right, 13, we actually have a picture of this on that blue sheet. This is theorem 3.7, which says if line A, so I'm going to call this line A, is parallel to line B, so I'm going to put some arrows on those to show that, and line B is parallel to line C. So this is line B is now also parallel to line C. Then what we can conclude is we can cut out the middleman, which in this case is line B. We can say, actually I'm going to use green here, line A at first line is actually going to be parallel to line C. So B is the middleman here. So now we're saying A and C are parallel, so we should have the same number of marks on those. All right, so that's the transitive property. We're cutting out the middleman and just saying the top line is parallel to this bottom line. Okay, the next one, number 14, has a lot of pieces of information there, but let's just take it step by step. First of all, line A is perpendicular to line B. Well, I'm going to make a vertical line and call it line A, and I'm going to make a horizontal line and call it line B. To show that these are really perpendicular, I need that right angle symbol here. So this means perpendicular. Okay, so now we already have this line B. We're going to make a third line C, so it's perpendicular to B. So again, make sure that has a right angle, and we're going to call this line C. And then we're going to make a fourth line so that it's perpendicular to line C. It doesn't matter where you do that. I'm going to do it above. So this is line D, and it is perpendicular to line C. So we've got all three sentences taken care of. We have A, B, C, D. We have 4 lines, so we are done. All right, next, let's flip to the back and look at number 15. They tell us the measure of angle 3 is 7A plus 13, so that's this angle here. And they tell me the measure of angle 2 is 133 minus 5A, that angle right there. And we're trying to figure out the value of A that's going to make P parallel to R. Well, these are corresponding angles, so if I can make those congruent, in other words, if I can make 7A plus 13 equal to 133 minus 5A, I can show that P and R would be parallel. So let's go ahead and solve that. First, let's move the 5A to the left by adding it to both sides. These will cancel. 5A plus 7A is 12A plus 13 equals 133. So we can subtract that 13 from both sides. And these will cancel. We get 12A equals 120. So dividing by 12 gives us A equals 10. So if A was 10, that would make this line P parallel to this line R. Okay. Our next example says, is line P parallel to line Q? Well, there's no arrows there, and there's no relationship between these two angles. They're not alternate interiors, they're not alternate exteriors, they're not consecutive interiors, and they're not corresponding. So they don't tell us anything. They also don't tell us that these are 90-degree angles right here, which if they were, we could use theorem 3.12. So we would have to say no, and I would say because there's no relationship between those types of angles, or there's no theorem that says anything about consecutive, or not really consecutive, but the same side exteriors. So we don't have enough information here. If we knew those two angles were 90 degrees, we could say that they were by theorem 3.12, but we just don't have enough information. Okay, let's look at our next examples here. Find the value of x, that would make M parallel to N. Well, if we look at our two types of angles, these are consecutive interiors. So if we can make those add up to 180, those two lines would be parallel. So let's take 3x plus 15, add this 75, and set that equal to 180. So I've got some like terms here. Positive 15 and positive 75 adds up to 90. And we can keep solving. Let's subtract 90 from both sides. We end up with 3x equals 90. And if we divide by 3, x is going to be 30. So that would make those angles supplementary, and that would make M parallel to N. Okay, in number 18, we had a few problems like this in section 3.6. So the first thing that I always look at is where do I have a match? In other words, where do I have two right angle symbols in line with each other? Well, the only place that I see that is for R and T. Those are both perpendicular to this line M. So theorem 3.12 tells us that if two lines are perpendicular to the same line, then those lines are parallel to each other. So R would be parallel to T by that theorem 3.12. All right, that's all you got to say. Okay. Next, number 19. We're going to create another sketch. The corresponding angles converse postulate. That's going to tell us, it's actually on your blue sheet of Chapter 3 Theorems and Postulates. If you look at the corresponding angles converse postulate, that's actually postulate 16, which tells you if you have two lines that are cut by a transversal, and say that you know this angle here is the same number of degrees as this angle here. This is an obtuse angle, so I'm going to say it's 110 degrees. And if I know this is also 110 degrees, then those two horizontal lines have to be parallel. So I'm going to draw the same picture, and then I'm going to include the fact that this line has to be parallel to this line. All right, so that's postulate 16 on your blue sheet. So I would make sure that you label the postulate and the theorems with their names. So if you don't have this name written under postulate 16, I would add that to your blue sheet. And I would do that for postulate 15, 16, theorem 3.1, 3.2, 3.3, all the way through 3.7. Okay, if you put some names with those, it's going to make your life a lot easier on the test tomorrow. All right, next part we have is another sketch. So we're going to draw line AB parallel to line CD. So I better put points A and B on the top line, and then points C and D on the bottom line. And to show that these are parallel, I need to put another set of arrows on there. All right, so that's the first part right here. The second part is telling us that ray CE bisects angle BCD. I don't have an angle BCD, so I'm going to connect B and C to create that angle. And C is going to have to be right in between this angle, so I'm going to put it right in between, or point E rather, is going to be right in between. And then I'm going to connect a ray from C through E. And it says that that ray bisects that angle, so I need to put marks that show that this is the same number of degrees as this. And you could put a degree measure here, like I could say this is 10 degrees and this is 10 degrees, but you don't really need to label them. As long as you have the arcs there, that shows that they're equal. Okay, we have one more sentence. Points B, D, and E are collinear. So here's my point B, point E, and point D. It looks like they're in a line, but in order to make sure they really are collinear, I have to connect them with a line segment or a ray or a line. So we have to show that they're collinear by connecting a line through B, E, and D. I actually used a line segment, which does the trick as well. Okay, we're just about there. Let's look at that proof. So the proof is kind of a long one. It's got quite a few steps, but the first 3 steps are using this given information. Line G is parallel to H, and you notice they put some arrows on here to show us that, so that was our first given for the reason. Then they tell us that the measure of angle 1 equals 60 degrees. So we'll write that for our second given. And they also tell us the measure of angle 4 is equal to 2 times the measure of angle 1. So that's our third given. So now notice right here, they took this measure of angle 1 and they replaced it with 60 degrees. Well, that's our second given. It's saying the measure of angle 1 is equal to 60 degrees. So if you remember, when you replace one thing with another, and that's the only thing that changes, that's substitution. All right, so we got that. Next step is just to multiply and simplify. So we know 2 times 60 is 120. So that tells us the measure of angle 4 is 120 degrees. All right, now to figure out part F, we're going to have to look at the picture. They tell us angle 1 or angle 2, this angle here, is congruent to angle 1. Well, if you look at that in relation to lines G and H, those two angles are alternate interior angles, and we know that alternate interior angles are congruent if the lines are parallel. All right, that's also, you could write for reason F, what theorem is that? That's just theorem 3.1, so you don't have to write that out, you could just write theorem 3.1. Okay, next reason is the definition of congruence. So if the angles are congruent, I know the measure of angle 2 is equal to the measure of angle 1. And then we're going to do a couple substitutions here. So up above, I have the measure of angle 1. If you remember up here in statement B, that was 60 degrees. So that means the measure of angle 2 also has to be 60 degrees. And now we're going to just do a simple addition statement. We're saying 60 degrees plus 120 degrees is 180 degrees. And then we're going to do substitution one more time. So now I know the measure of angle 2 is 60 degrees. So I'm going to replace this with the measure of angle 2. And I also know from up above the measure of angle 4 is 120 degrees, so I can replace this 120 degrees with the measure of angle 4, and that's still equal to 180 degrees. All right, well now I know from this statement that 2 and 4 are supplementary. Well, hey, if two things add up to 180, then they're supplementary. That's just the definition of supplementary angles. Okay, and last but not least, let's go back to our picture. So we've got all of this information, and now we can conclude that this line P is parallel to R because we know this angle 2 plus angle 4 is equal to 180, or that they're supplementary. That is consecutive interior angles converse, which on your blue sheet matches with theorem 3.6. All right, well, I appreciate you guys watching. If you have any questions, see me before the test. All right, thanks, and we'll see you later.